Hello everyone. In this video, we will be discussing a small topic from the subject of geography, that is the pressure belts. Many aspirants find geography as a difficult subject because most of them do not completely understand the concepts of the subject, and instead they will try to mug up or by heart most of the topics. So, geography is an easy subject if our approach towards it is like we are understanding the concepts, we are consuming the concepts very well, then we are applying it. So, here in this video, we will be discussing the concept behind the atmospheric pressure belts. So, to begin with, what is atmospheric pressure? To give a simple definition, we can say it is the pressure exerted by the atmosphere on the surface of Earth. Pressure exerted by the atmosphere on the surface of Earth. So, we can also say it is the weight of the air column in the atmosphere which is applied on the surface of Earth. So, as a simple word, we can say it is the pressure exerted by atmosphere on the surface of Earth. And we know that there are several factors which affects the pressure of a region. Temperature, wind, there are several factors. So, the pressure over Earth, it varies from region to regions. So, our Earth, we can divide it into 7 major pressure belts. We can divide our Earth into 7 major pressure belts. So, what is a belt? Belt is something which is circumnavigating around a body, isn't it? So, we have some pressure belts that is circumnavigating around the Earth. For example, if you are considering low pressure, the low pressure region which is circumnavigating around the Earth, that is the low pressure belt. Similar is the case of high pressure belt. So here in Earth, we have 7 major pressure belts. Out of these 7 major pressure belts, 3 are thermally induced and 4 are dynamically induced. 3 are thermally induced, 4 are dynamically induced. I will explain what is thermally induced and dynamically induced, but for the time being, just keep in mind that 3 of the pressure belts are thermally induced, 4 are dynamically induced. We will see how. Okay, consider this circle is our Earth, and in our Earth, I am going to draw the equator. This is our equator. We know that in our Earth, equator, the temperature is very high. In the equatorial region, the temperature is very high. Temperature is very high means the air will be heated up and the density of the air will decrease. If temperature increases, density of the air decreases. Less dense air means it will rise upwards, isn't it? Less dense air always rises upwards. So, in the equatorial region, we have the upward movement of air due to the high temperature. So, I have marked the upward movement of the air like this. Just imagine it or visualize like it's rising from the surface of Earth. So, here I am demarcating it in this direction. So, we have the rising of air upwards in the equatorial region due to high temperature. Remember, atmospheric pressure is the pressure exerted by atmosphere on Earth. But in equatorial region, the air is having the tendency to move upwards. So, it's not coming down, it has tendency to go upwards. So, atmospheric pressure in the equatorial region will be low. So, the pressure belt at the equatorial region, we call it as equatorial low pressure belt. So, at the equatorial region, we have equatorial low pressure belt. Now, we will move to the polar regions. Okay. In the polar regions, we know that temperature is very low. Temperature very low means the density of the air will be very high. Density high means the air will be sinking. So, more pressure will be applied on the Earth's surface. So, due to that, in the polar region, we have the sinking air. I will draw the sinking air like this. We have the sinking air. And due to that sinking air, we have the high pressure in the polar region. And we call the pressure belt at polar region as polar high pressure belt. So, we have the polar high pressure belt on the northern hemisphere, that is the North Pole, and also in South Pole. So, we have 2 polar high pressure belts and 1 equatorial low pressure belt. So, these are the 3 thermally induced pressure belts because these 3 pressure belts are formed due to the temperature difference. At the equator due to the high temperature, at the polar region due to the low temperature. I will draw that arrow on the polar region also. South Pole. Okay. So these are the 3 thermally induced. Now we have to see regarding 4 more pressure belts which are dynamically induced. Okay, listen. So in the equatorial region, the air is rising upwards due to the high temperature and low density of air. Air, as it moving upwards, we know that in troposphere, as we are moving upwards, there is fall in temperature. So the air starts to cool down. Air starts to cool down means there will be increase in density of the air. So the air won't be able to move further upwards. The air is rising from the equatorial region due to the low density. But as it is rising, there is fall in temperature and increase in density. So it cannot move further upwards. But there are continuous supply of air from the bottom. From the bottom, the air is keeping on rising. But the air cannot rise further upward due to the high density. So what happens? The air splits into 2 branches. One branch moves towards the southern hemisphere, while the other branch moves towards the northern hemisphere. Okay, the air splits into 2 branches. One branch moves to the southern hemisphere, other branch moves to the northern hemisphere. So remember, now the air is moving away from the equator. It is moving to the north and south as well. So there will be further fall in temperature. So the density of this particular air mass will increase. Density increase means it will start to sink. So here we can see the air sinking over this region. On both the hemispheres, the air is sinking down. Air sinking down, that means air is going to apply more pressure on the Earth's surface. So over here, we are going to get yet another pressure belt, and these pressure belts over this region where the air sinks is called as the subtropical high pressure belt. On both the hemispheres, we have subtropical high pressure belt. Now listen, along the subtropical high pressure belt, I have shown you the air is sinking. Air sinking on reaching the Earth's surface, it cannot move further down. It again splits into 2 branches. One branch moves towards the equator, other branch moves towards the poles. Same thing happens in the southern hemisphere also. One branch moves towards the equator, other branch moves towards the poles. Okay, let it be there. Now we will move to the polar region. In polar region, the air is sinking. The air which is sinking on reaching the surface of Earth, it moves towards the subtropical region. Here also moves towards the subtropical region. So you can see over here, over this portion, the air from the polar region and air from the subtropical region, they are both meeting at this particular point. So listen, air from the polar region means it will be cold air. Air from the subtropical region, that means it is going to be warm air. So here we have a meeting of warm air from subtropical region and cold air from the polar region. So when the warm air from the subtropical region and cold air from the polar region meets, warm air being less denser rises upwards. So here we will be having an upward movement again. So in both the sides we have the upward movement. And as it reaches an altitude, it again splits into 2. One branch moves towards the poles, other branch moves towards the subtropical region. Here also, one branch to the subtropical region, other towards the poles. So here, over this point, you can see the air rising upwards. Air rising upwards means it is opposing the atmospheric pressure. So here, the atmospheric pressure over this region will be getting a low pressure belt, and the low pressure belt which is obtained over this region is called as the subpolar low pressure belt. Subpolar low pressure belt. So now we have got the 7 pressure belts. We have 1 equatorial low pressure belt, 2 subtropical high pressure belts, 2 subpolar low pressure belts, and 2 polar high pressure belts. Low pressure means the region where the air is rising upwards. High pressure means the region where the air is sinking downwards. So that is very easy to remember. Okay, so listen, in the equatorial region the air is rising, in the subtropical high pressure belt air is sinking, in the subpolar low pressure belt air is again rising, and in the polar high pressure belt the air is again sinking. Now if you watch carefully, you can see that there are 3 cycles or 3 cells which is happening under this process. You can see between the equatorial low pressure belt and subtropical high pressure belt there is a cell of air movement. Between subtropical high pressure and subpolar low pressure belt, we have yet another cell of movement. Between subpolar low and polar high, we have another cell of movement. The cell between subtropical high and equatorial low, that cell is known as the Hadley cell. Similarly, the cell between subtropical high and subpolar low, it is known as the Ferrel cell. Then, between subpolar low and polar high, we call it as the polar cell. Same is the case in the southern hemisphere. Between equatorial low and subtropical high, Hartley. Subtropical high and subpolar low, Ferrel. Subpolar low and polar high, we have the polar cells. So, these particular cell movements along with the temperature difference causes the 7 major pressure belts of Earth, out of which the equatorial low pressure and the 2 polar high pressure are the thermally induced. The 2 subtropical high pressures and 2 subpolar low pressures are the dynamically induced pressure belts. So, this is how you can easily understand the concept or the mechanism of the formation of the different pressure belts on Earth. These pressure belts are very important because when we are going to study the next topic, that is the wind and all, in the topic of wind, when you study the primary prevailing or permanent wind, you need to apply this figure. Then it will be much more easier. So, try to understand the topics of geography in such a conceptual, with conceptual clarity rather than studying it by heart. So, all the best. See you again. Bye-bye.